Welcome to this explainer. Today, we're unlocking the absolute ultimate guide to mastering two of the most crucial data structures you're ever going to encounter in technical software engineering interviews. I'm talking about the HashMap and the HashSet. If you're diving into data structures and algorithms right now, or you're gearing up for those high-stakes coding assessments, understanding the precise differences between these two, well, it's completely non-negotiable. So let's get right to it.
Okay, let's dive into this, because this quote perfectly summarizes the sheer high stakes of today's topic. I mean, mix them up and your code breaks. It's that simple. These two data structures solve completely different problems. You can't just pick one at random, cross your fingers, and guess which one fits. If you mix them up during a coding assessment, or worse, in a real production environment, your code is going to break. Or at the very least, it'll perform so poorly that it completely fails its fundamental purpose.
We've literally all felt this relatable dread. You're staring at your screen, you've written out your entire solution, you know for a fact that your logic is absolutely 100% perfect, but then you hit run, and boom, you're hit with that glaring red time limit exceeded error. So why is your LeetCode timing out? Well, almost always, the culprit actually isn't your overall logic, it's the underlying data structure you chose to power that logic.
The stakes, broken code. Let's establish exactly what these two data structures do and why understanding their fundamental distinction is so vital to your success.
Now, what's really interesting about this slide is the stark baseline contrast between these two tools. This is the core difference, the foundation that everything else flows from. A hash map stores key-value pairs. Think of it kind of like a standard dictionary where you have a word that's your key and its definition, which is your value. A hash set, on the other hand, it stores only keys. There's no accompanying value at all. It's simply a collection of completely unique items. But here is the absolute algorithmic superpower they both share. Big O of 1, the holy grail of algorithmic time complexity. Both the HashMap and the HashSet give you an average lookup, insert, and delete speed of O of 1, constant time. That means whether you have 10 items in your data structure or, 10 million items, it takes the exact same instantaneous amount of time to find what you're looking for. It's literally algorithmic magic.
Section 2. HashMap, the frequency counter. Let's shift our focus entirely over to the HashMap for a second to explore its specific superpower. Take a look at this breakdown. Whenever you need to track relationships, locations, or counts, a HashMap is exactly the tool you want to reach for. Just looking at the use cases on the left side here, you use a hash map when you need to count frequencies, store mappings, or track index positions. So practically speaking, as you can see in the examples on the right, this is absolutely perfect for counting character frequencies in a string, or maybe mapping a specific value right to its exact index position in an array. Basically, you have the item, and you have the specific data associated with it. And hey, if you're working in Java, you've got to notice this map.getOrDefault syntax. Honestly, this is the absolute cleanest way to handle missing keys in your code without throwing those annoying errors. If the key exists, boom, you get its value. If it doesn't, you get a nice, clean baseline of 0. It's elegant, it's super safe, and trust me, it is a massive time saver during those high-pressure coding interviews.
Section 3. HashSet, the existence checker. Let's move to and see how this builds into the HashSet side of things.
So the crucial point is that a hash set is strictly for answering binary yes or no existence questions. That's it. You only use a hash set when you just need to check existence. Like, does this element exist, yes or no? As the examples show here, this makes it the absolute perfect data structure to check for duplicates in a massive data set, or to really quickly find elements that overlap between two different arrays. You don't care about any value attached to it, you just care if it's actually there.
This incredibly simple Java call, set.contains, is exactly how you access the hash set's lightning-fast power. You just feed it an element, and because of that amazing O of 1 constant time we talked about earlier, it tells you instantly if that element exists in your set. No searching, no endless looping, just an immediate, on-the-spot answer. Section 4. The fatal timeout trap. Now, I need to warn you about the most common mistake developers make that completely ruins their algorithmic performance.
I seriously cannot warn you about this explicitly enough. Using a standard list with the .contains method scales terribly compared to our O of 1 hash set, like terribly.
List.contains is an ON operation. HashSet.contains is an O of 1 operation. For large inputs, making this simple mistake, reaching for a list instead of a hash set just for existence checks, is literally the fatal trap. It's the difference between passing the test cases and completely timing out. Let's just remind ourselves what O of n actually means in practice. It's a time complexity where execution time grows linearly with the size of the input. So, if you use a list to check if an item exists, your poor program has to search through every single item in that massive list one by one until it finally finds it. That is exactly the bottleneck that triggers that dreaded time limit exceeded error we talked about earlier. Section 5, the golden rule. Let's clear up all that tension with the ultimate rule of thumb to memorize and reflexively apply. And this brilliantly illustrates our final takeaway. Here is the golden rule. If you need both the key and a value, use a hash map. If you just need to know if something exists, use a hash set. It really is that straightforward, guys. Hammering home this exact dichotomy between key and value versus pure existence is going to save you endless hours of debugging time. I want to leave you with a bit of a challenge today. Go look at your current code base right now. Seriously, how many O of n bottlenecks are hiding in there? How many lists are quietly slowing down your entire application right in a spot where an O of 1 hash set perfectly belongs? Take this knowledge, immediately audit your code, and optimize your approach. Thanks so much for joining me for this explainer, and hey, happy coding.